Previously we talked about the open molding process, now we talk about the closed molding process. And all the while we are talking about manufacturing process, where you're talking about manufacturing the composites. Okay, so therefore for closed molding in these slides, alright, in the slides that is provided, only 3 things are being discussed, alright, while the rest are not discussed. And therefore in this video I hope to address 3 of this thing in this video. In the next video I'll briefly touch on the things that is not touched in this in the slides. Alright, and therefore let's start off with the pultrusion, which is the first one, and see how it goes. Okay. So therefore, over here the first step is that there will be a fiberglass rovings. Fiberglass rovings are just like this thing, alright, where when they feed, they are actually feeding only a strain of the fiberglass, where the fiberglass mat is feeding in terms of a toilet paper. When you feed, it's fixed in a piece like this. So for a roving, you should remember it's feeding a strain of fiber. Over here it's feeding a piece of the fiber. So if I were to zoom in all straight up, alright, as you can see, this is feeding in terms of a paper. This is all feeding in terms of a strain, as you can see. Alright. So over here, your resins will be impregnated, or in other words, being coated with a certain, your fibers will be coated with a certain resin, alright, and therefore it's being coated in this part over here. Then after there will be a certain surfacing material, which is I believe is to protect the resin and the fibers, alright, where this is the part where they feed in the surfacing material. Okay. So roughly you would understand where it comes from. Okay, is that this part over here will try to pull all this material towards the side. Alright, and once you pull over at this side right now, there will be a cutter over here to cut it. So you have this material. So this material will go into this roller and you'll roll to somewhere else for packaging or whatever already. And therefore this is somewhat the pultrusion manufacturing method. To better sink into you, alright, the whole pultrusion method, in terms of a real life manufacturing thing, so you can just watch here.
What is pultrusion? Pultrusion is a manufacturing process for producing continuous lengths of fiberglass reinforced plastic shapes with a constant cross-section. While pultrusion machines vary in design, the process is basically the same. Let's first start with the fiberglass reinforcement. Creels of unidirectional roving provide longitudinal tensile strength, or the strength along the length of the profile. Rolls of continuous filament mat, woven roving, or stitch fabric provide the profile with its transverse properties or its strength across the width of the profile. All reinforcements are first fed through preforming pies that will begin to shape the raw glass fibers into the finished profile. The glass is then pulled into a resin bath that saturates or wets out the reinforcements. The resin bath contains a mixture of resin, most commonly polyester or monoester, pigment to add color, filler to enhance properties, and a catalyst to aid in curing or to turn it from a liquid to a solid. Surfacing veil is added to give the profile a resin-rich surface and enhance the appearance of the final product. The wet-out reinforcements now enter the heated pultrusion pot. The heat begins the thermosetting reaction process that cures the finished profile. The cured profile is now advanced by a caterpillar-style puller to the cutoff saw, where it will be cut to its final length. The finished product is now put into inventory at one of our warehouses, sent to our state-of-the-art fabrication center for secondary processing, or created for shipment to the customer.
Slides actually didn't explain much about pultrusion, so therefore it's being referred to the reading materials over here. Alright, and pause the video and read and see which are the things that you need, and then you highlight yourself. Alright, so over here there are certain things that you can take note, is that the solid and hollow sections can be produced with a quite complex cross-sectional shape. So yeah, when talking about pultrusion, you're talking about certain cross-sectional system. Alright, it can be either an I beam, or a H beam, or just a simple hollow beam. Alright, if you were to go into 3D. Okay, so when you're manufacturing all these things, you're actually manufacturing a beam. Alright, so yeah, as you can see, so the process is consistent quality and high rates of production. Alright, and requires lesser labor comparatively to other manufacturing methods like hand layout and etc. Alright, so in terms of labor cost, pultrusion is relatively cheaper and is more of a machine-based system. Alright, so besides pultrusion, alright, there is also called the pulforming, alright, where this allows a curved shape to form with a variable cross section. Alright, next thing you may wonder is that it's formed with variable cross section. Alright, so I'll just repeat again, is that pulforming is for curved shape, alright, to form variable cross section, provided cross sectional area constant. Alright, it's like here say constant, the other side it says varying. So therefore, what is the meaning is that this is the picture over here. So over here you have a certain shaping die. So this shaping die over here will shape your certain size. So over here is a constant cross section. So there will be a certain rotating thing such that it will create a certain shape. So once you create this shape out, alright, this, if you look at this point, this is another cross section. So this cross section is different from this cross section, where this cross section over here is for this part, the cross section of this banded thing. So if you were to go all the way, alright, and become like that, alright, this whole thing, if you were to look in this direction, is a cross section also. So therefore over here you can create a curved cross section, while with a constant cross section with a shaping die. Okay, and therefore this is the thing for the pulforming. Okay, and that for pulwinding is a combination of pultrusion and filament winding, which is the one filament winding we said it before, so I'll not go into details, but at least you get to know a few stuff of it. Alright, so over here I would suggest you can understand and memorize the pultrusion advantages. Alright, and these are the things, especially the low cost, low labor, high production, things like that. Okay, it's for pultrusion only, not pulforming. I think for pulforming also can. Alright, and actually both, all of them, pulforming, pultrusion, pulwinding, or everything. Alright, so therefore I think I'll just stop here because it's quite a heavy thing in this section. Alright, and therefore I've done the pultrusion, so we'll talk about the resin and vacuum bag in the next video then. See ya there.